Hey guys, today we're going to talk about scientific notation. So scientific notation is a method for expressing a given number multiplied by 10 to the appropriate power. So when do we even care about scientific notation? It's when we're dealing with really, really large or really, really small numbers. So for example, we're going to learn just how to go back and forth between numbers written in standard notation, so just their normal number, and numbers written in scientific notation. So in this first example, I have 78,256,000. That's a really large number. We want to be able to write this number in scientific notation. What you're going to do, whether it's a large or small number, is find its decimal. Well, at the end of every whole number, the decimal is at the back. Okay, and then what you're going to do is you want to move that decimal so the number is now a number that is between 1 and 10. So we're going to make the larger number look or appear smaller. So we're going to move this decimal place 1, 2, 3, 4, 5, 6, 7 places. So now my decimal point is between the 7 and the 8. So this is going to make it 7.825600. You don't have to add those zeros. Times 10 to the power of how many times you move the decimal. So I move the decimal again, 1, 2, 3, 4, 5, 6, 7. So 10 to the power of 7. So now 78,256,000 has been rewritten, right? These two numbers down here are equivalent as 7.8256 times 10 to the power of 7. Okay, if you have a small number like we do in example 2, which is 0.00401, you again want to take this small number and make it appear bigger by moving the decimal place. So again, the number is now between 1 and 10. So I'm going to find my decimal. In this case, the decimal point is right here. And I'm going to move it 1, 2, 3 places. So the number is now 4.01 times 10 to a new power. Okay, well, the last time our power was 7, positive 7. Or this time, because we have a small number, our exponent is going to be negative. So this is going to be 4.01 times 10 to the power of negative 3 because I moved my decimal place 3 times. Okay, now let's go in the other direction. So in these next two examples, I'm giving you a number in scientific notation, and I want you to write its standard form or the original number. So in example 1, I have 6.2 times 10 to the power of 3. So I'm going to take the decimal, which is 6.2, and I'm going to take it and I want to move it 3 places. Now it's a positive exponent, so that means my number is going to be a big number. So I want to move my decimal so my number is bigger. 1, 2, 3 places. Wherever there's these missing like swoops, you're going to just fill in with zeros. So 6.2 times 10 to the power of 3 is really 6,200. And that's going to be that answer in standard form. In example 2, we have 4.5 times 10 to the power of negative 4. So we're going to do the same thing, but this time I have a negative exponent, which means my number is going to be smaller. So I'm going to take my decimal place, 4.5, and I'm going to move it 4 times to make my number smaller because it's a negative exponent. So 1, 2, 3, 4. In this case, I have 3 zeros I have to fill in, and because it's a small number, I need to include that decimal. So my standard form answer for 4.5 times 10 to the power of negative 4 is 0.00045. So the hint here is that, oh, this kind of got a little messed up, but it shouldn't be on your notes. But here we have large numbers, okay, or big numbers have a positive exponent, okay, and smaller numbers have a negative exponent. So that's kind of the hint. Large numbers have positive exponents, small numbers have negative exponents. So now, of course, why are we doing this in our exponent laws unit? Because we can take really big numbers and really small numbers, and we can multiply and divide them. And instead of going back and forth between standard notation and scientific notation, we can just use our exponent laws. So we're going to evaluate the expression, and answers should be in proper scientific notation. So here, all I'm doing is I am multiplying, in example 1, 5.6 times 10 to the power of negative 4 times 1.4 times 10 to the power of negative 5. So here I can see that I'm obviously multiplying, and I'm going to multiply like bases. Well, again, numbers are like bases. So I'm going to do 5.6 times 1.4. which is 7.84, okay? And then this is going to be times 10 to the power of 10 to the negative 4 times 10 to the negative 5. When you multiply like bases, you add your exponents. So negative 4 plus negative 5 is going to be negative 9. So my final answer is going to be 7.84 times 10 to the power of negative 9. So again, that's a lot better than having to go back and forth between standard form and scientific notation. All right, in example 2, I have 3.5 times 10 to the power of 3 divided by 1.7 times 10 to the power of negative 5. So here I'm dividing, and again, I'm going to divide my like bases. So 3.5 divided by 1.75 is 2. So those are my number bases that I'm dividing. And then it's going to be times 10 to the power of negative 3 minus negative 5. Dividing my like tens, you subtract the exponents here, so this is going to be to the power of 2. And then that's going to end up being my final answer because it is in proper scientific notation.